Hello everyone, welcome to my channel on data analytics. I am your host, Professor Rage Udaikiran. In this video, we are going to learn how to generate the statistics of a database for which the user is going to discover the patterns. The outline of the presentation is as follows. First, we discuss the importance of knowing the statistics of a database. Next, we will be looking at the various types of statistics that we can generate using the algorithms in PAMI library. Next, we briefly discuss and introduce the dbstats subpackage that is available in PAMI library. Finally, we provide a small demo on how to generate the statistics of a database. Coming to the importance of a database statistics, every data scientist, before executing any machine learning algorithm, must first understand the statistics of a database. The reason is the statistics of a database play a crucial role in parameter selection and algorithmic selection. For instance, if we consider the parameter selection, if the user is not careful, okay, for if he specifies high threshold values, then he may miss something that is interesting to the user. Similarly, if we specify very low threshold values, then too many patterns may be generated. Sometimes algorithms may run out of memory also. That problem exists. Similarly, when we are talking about algorithmic selection, every algorithm has its own strength and weaknesses. So, a algorithm that is best for one data set may be worst for another data set. So, it is important to understand the statistics of a database. For instance, assume your dataset is a sparse dataset. In that case, FP growth is the best algorithm to choose and mine patterns. However, if your dataset is dense, then FP growth is not the best algorithm for your case. It is the eclat diff set. So each algorithm is best for particular type of a database. So it is important to first check the statistics of a database and then choose which algorithm to mine. Now, coming to the various types of statistics supported by the programs in PAMI library. So, in the when we are designing the PAMI library, we thought of dividing the statistics into two types. One is the basic statistics that exist for every database format, whether it is a transactional database, temporal database, utility database, whatever is the format of the database, these statistics exist. The another set of statistical parameters are specific to the databases. For example, if you look at the basic statistics, every dataset will have the total number of items, total number of transactions, what is the sparsity of the data, so on and so forth. Similarly, if we look at data specific statistics, then they change. For example, if your input is a temporal database, then we have additional statistical parameters such as what is the maximum periodicity that was found among all the items, what is the average periodicity of all the items, then what is the distribution of item periodicity values, and so on and so forth. So when the user is trying to find the patterns, they first have to study these statistics. So how do we extract these statistics using the PAMI library? To find the patterns, you have to use the dbstats subpackage that is available in PAMI. In this Anyone can call this package using PAMI, extras, dbstats. In this subpackage, we have several algorithms. For example, transactional database.py. This program will take the input, a transactional database, and prints all the statistics of it. So every fu- since there are basic stats and database specific stats, and user may not know what are all available, we have come up with a nice idea. That is, we have created two functions: print function and print stats function and print graph function. Print stat function will print all the database statistics that are gathered for a particular database. Similarly, print graph function prints all the graph distributions that are gathered for a particular database type. So, if you are not familiar with what are all the parameters that we are capturing, statistical parameters that are capturing for a database, no need. Simply call the algorithm that measures the statistics of a database and simply say print stats and print graph. These functions will print all the statistics captured with respect to the format of the database. Now, let us look at a small demo. So, let us first install the PAMI repository. So, pip install PAMI. So, first let us install the PAMI package. While this PAMI package is getting installed, let us visit to my web page where we have various formats of the data. So for this example, let us choose the synthetic dataset T10 I4 D100K. Now we have installed the library. Now let us download the dataset. So now we are downloading the dataset. Now what we do is, now that we have installed the PAMI library and we have downloaded the dataset for our experimentation, now let us first learn how to extract the statistics. So from PAMI extras, and then we can see dbstats. So from dbstats sub package, let us import. So we want to take the transactional database. So let us import it as an algorithm. Once we import this algorithm, now what we do is, let us create an initialize it using algorithm dot transactional database. So in this one, we have to provide the input parameters, data frame or string. So we are going to input the string as the file name and then the separator. Since the default separator is tab space, we don't need to mention it. We simply mention the file name. So let us copy it here and then let us specify the, if you want, we can also specify the function. For example, tab space. Okay. Otherwise, you can also use any. My dataset is tab space, so I am going to use tab space. So we have now initialized it. Now what we are going to do is, we are now going to run the algorithm. So obj dot run. So now this program will execute and then it will print the statistics. For example, if we want to print, we can simply say print obj dot database size. This function will print the total number of transactions that exist in the database. So anyone can call the particular function to print the statistics of a database. However, if the user is not familiar with the various functions that are available, then user can simply say obj dot print stats. So this function will print various statistics that we gather for the transactional databases. While it is running, we will also try to print the distribution graphs. Okay, so let us say obj dot print plot graphs. The plot function will plot the graphs, that is the distribution graphs for how the frequencies of the items are and how the transaction lengths are. So this information is crucial because if we want to specify a minimum support like parameter to find frequently occurring patterns, it is very important to have. You can see that our data set is very sparse, and then this is the distribution of the items and the transaction length distribution. So we can see that most of the transactions contain, okay, 10 length. So transaction length. So many transactions in the data set have the length of 10 items. So this is how we can generate the statistics of a database using the PAMI library. If you have any questions, feel free to post them in the GitHub issues or GitHub discussions of the PAMI library. Thank you very much for viewing our video. If you like our work, please press the like button, share it with your friends, and subscribe to the channel for more updates. If you want to know more on the generating the statistics of a database using PAMI library, please check the link provided below.